So for a more complex example here, we have our inventory base address with our offset chain. Now, originally I found this as the third slot of your inventory chain. So I had this base, these offsets, followed by C0 to 10. Upon further observation using ReClass, we determined that it was actually the inventory manager data structure, and that by taking off the last two offsets and using them in this function right here where we can ask for user input on what slot they want to modify, we take a pointer, we add the A0, which in this case is the first slot available, and then we add the slot times 10. And essentially this lets us just crawl through the structure, and I'll show you that in a minute. And you always have to have the 210 or else you'll never actually get to the value located in the slot. You'll just get to the slot itself. So as I say here, this allows you to choose on the fly which slot you want. There are 9 total slots. And this allows you to get the value of ammo located at that slot. Now we will go into our ReClass and I will show you what this looks like. So here we have our base address right here, same one. So inventory manager. So right away we know we have a pointer to 360. So we create a class pointer. We populate this with bytes. We scroll down to 360. Now we're here. We created a class pointer. We know we have another pointer at 58. We create another class pointer, populate it. Now we know this one's at 8, so it's actually very easy. It's right here. Create a class pointer, we populate it. Now we have to go down to 150. Now we're at 150. So if we scroll down here, we notice that originally for C0, we would end up right here, okay? And now the interesting thing you notice is that up here in red, it says C inventory. So that's a dead giveaway that we're now in the inventory data structure. The data and then the module and the address, this is just telling you what module you're currently located in. Anything under it, basically, is what that goes to. And all these heaps are pointers. So we're in a module labeled inventory with lots of pointers. What could this possibly be? Well, at C0, we continue down the chain. We need to go to 210. So we go to 210, we create another class pointer, and then we insert 4 bytes, and then we change it to int32, and right here we can see we have our ammo, 6. So as I said, originally this was for a revolver in my third slot. So we got to thinking maybe all the things above it with the C0, maybe B0 is something. Maybe they kept like a common naming scheme. Basically they kept it a very specific amount of bytes apart. So we tried that. So B0 at 210 at 4 as an int32 gives me 10, which is the amount of ammo in the magazine of my secondary slot weapon. So we're like, okay, cool. What about A0? Sure enough, at 210 at 4, first slot ammo, 4. Now I went ahead and labeled this. When you first go through here, it's just going to be like N with a bunch of numbers on it. So you're going to have to be sure that you know what you're looking at before you go around labeling stuff, or it's all useless. And we can confirm that this is the first slot. So it says 4. So we open the game. I'm holding my primary rifle. It also says 4. Well, let's change this. 5. And in the game, it says 5. So that confirms that this is our first slot ammo. Let's just change that back. So we're back. So then we go down to B0, just to prove to you that this is what it is. B0, 210, 4 bytes in, int, 10. So in the game, 10. Let's change it to 20. 20. It does have a side effect of making your reserve ammo go negative. That has no effect whatsoever on you actually using it, as you can see. Let's just change it back to 10. And there we go. And that's how you can map out a large data structure and how it can assist you in your programming. Because we were able to confirm through using ReClass that this was the inventory manager. Then we were able to implement it into the code with this little math problem we came up with. Now it works. So now all we have to have is the most basic pointer to the inventory. The rest is just taken care of dynamically.